Okay, in this video we're going to have a quick look at converting between binary, hex and decimal. So we'll start off dealing with our binary numbering system. Okay, so binary is a base 2 numbering system, so the same as we would have when we're dealing with decimal. Each column, we've got our units column, our tens column, and hundreds, thousands. So we've got so many number of units, so many number of tens. Well, this means we only either have 1 or 0 with our binary, so we can have one lot of 1s, one lot of 2s. So this is what each of our column means. So if we had a binary number something like that, in terms of a decimal, so in terms of a decimal value, then that would be 128 plus 16 plus 8 plus 2 plus 1, which is 255 in decimal. Okay, so there's our binary, and we've just converted it into decimal. If we want to go the other way around, we do this do a similar task. So in converting, so we'll have, say, 203 decimal into binary. So can we do 128 into that? Yes, we can. So and then we can do a 64 as well into that, but we can't do a 32, can't do a 16, because we've got we can do an 8 and 2 and a 1, so that should make 203 if my maths is correct. And there we have our decimal into binary. So if we want to convert it into a base 16 numbering system, hexadecimal, let's just remind ourselves about what hexadecimal is. I'll put it down the side here. So down the side there, so hexadecimal, it's a single digit. As soon as we get past 9, then we use letters A to F. Okay, so we're converting binary to hexadecimal, because to create a single digit can be made up of 4 bits. What we can do with our binary word is to split it up into 4 bits. Let's give an example and you'll see what I mean. So if we have this binary value, I can put an imaginary dotted line just here, and then I can look at, well, what do those actually mean as just as 4 bits on their own. So I've got an 8 and a 1, so that would be the equivalent of 9. And then we'll start again, just looking at if I just had those 4 bits, irrespective of them being the most significant nibble of that word. So I've got an 8 and a 4, so that's 12, and a 1 makes 13. Now 13 is D, so that becomes D9. Okay, do we just have one more example? So we have something like this, imaginary dotted line down the middle. So what we got now, we've got an 8 here, 9, 10, 11. 11 is B, and then here we've got an 8 and a 4, so that's 12, so that's C. So CB would be our interhex. Okay, if we're looking to convert something from hex to binary, then we just do exactly the same, but just in the reverse. So what should we have? We have A, E. Okay, so converting that back into binary, so E is equivalent to 14, so that's going to be 1, 1, 1, 0, and then A is 10, so that's 0, 1, 1. Let's take that, 8 and a 2, 10 and 14. So nice and easy. If we want to go from hex to decimal, then I suppose we could go from hex to binary and then from binary to decimal. But what we can do is we can multiply out the same way as we did originally with our binary, knowing what each of the columns worth. So if I just mark that out, so as hex is a base 16 numbering system, so same as we had before with our binary and we'd have with our decimals, whatever we've got in this column is just multiplied by 1. Then once we've got, because we can have 0 to 15 equivalent, because f would be 15 in the column, then we'd have it 16, so we'd have however many 16s, and then we can have however many 256s. And that should do us really for now. Okay, so let's have an example. So if I have something like that, 03b as my hex value, and then I want to convert that into decimal, then I've got 3 times 16 plus b is 11. So that gives me 59 in decimal. Okay, and that's all we have to do. We'll do one more, or I think we've got the idea. So however, whatever the column's worth. This column is worth 1, 16s, 2 5/6s. Let's do it the other way around. I only wanted this to be a short video anyway. So if we want to do decimal into hex, what we have to do is we have to go back to primary school sort of division and look at how many 16s go into the whatever number we've got and whatever the remainder is. Okay, so if I take 158 decimal and want to turn it into that, so I say how many 16s go into it. Well, I don't know how to write that shorthand, so I'll just say divided by 16. So how many does that go into? So it goes 9 times remainder 14, and then what we should do then is we should take the 14 divided by 16 goes nothing remainder 4. Oops, sorry, done that wrong. And then we should take goes 9 remainder 14. So then we should go 9 divided by 16 goes 0 remainder 9, and then we read back up. So that's the way that we read our number. So what we've got is looking at it. So we've got 9, and then 14 is E. So 158 decimal is 9E X. So why do we do it the way we've done it? Because you might say, well, I already had my answer here on that line there. Okay, so let's take a slightly bigger number and look at this. So we've got 270 divided by 16. Okay, what happens? We've got 16 remainder 14, so I'll leave the 14 there, so I'll bring the 16 down. 16 divided by 16 goes 1 remainder 0, bring the 1 down, 1 divided by 16 equals 0 remainder 1. So then if we read it back up like that, then we've got 104 in hex, which makes sense because that would be one lot of 256. Sorry, 10E, I beg your pardon, so I misread that one. 14, so 14 is E, so it would be 256, nothing in this column, and then E is the equivalent of 14. So 256 plus 14, it would actually give me then 270. That's why we read it. That's why we do that successive division and then read it back up that way.